Okay guys, so for this next module we will learn how to really interact between RoboDK and the real robot, which is oftentimes the end goal. So if your end goal is not to do just simulation, your end goal is to do offline programming, you need at some point to go from RoboDK to the robot. So this is what we'll discuss today. So before we even go there, I just want to say that there's kind of two ways to interact between RoboDK and the robot. So you have the post-processor way, which we will cover today, and you have the driver way, which we'll cover in the next little module, section in fact. So the way with post-processor, the concept is pretty simple. You use RoboDK to create your program via the virtual environment. Then you generate the same kind of code you would have generated if you kind of programmed the program by hand. So if you just sit down with a text editor, and said, okay, I'm gonna write down some robot code, it would look pretty much the same way as if you did it in RoboDK, took your program, right-click, generated the program, and then received the file. So if it was, I don't know, a program for KUKA, it's supposed to be a .src. So if you took your .src file and the .src file RoboDK created, those should be pretty similar. The one from RoboDK will be obviously a bit more generic and robotized or automated as a way of programming, if I can say. But yeah, so that's the first method. Then the second method is with the driver. So with the driver, you need to have a live connection between the robot and RoboDK. The robot will generally be in kind of a listen state, where it will wait for the commands from RoboDK to come in. This is another very cool feature. It will be this way you'll have what we call kind of digital twins. So you'll have the robot in RoboDK doing a motion and the robot in real life doing the same motion at the same time. Like they're pretty well timed, if I can say. And you can also go ahead and retrieve information like joint position or target position with the driver, which will be useful for other steps we need to take to set our station. We'll talk about that in 2 sections. So yeah, so you have driver, you have post-processor, you have driver, and we will explore both of those in the next few videos. So let's start with generating a path. I'm gonna bring that here. Sorry. So let's talk about generating a robot program. So let's create a simple path here. I'm gonna go ahead and take this here. I'm just gonna take a tool that is very small. Where are my tools? Here. Do I have the pen? No, I don't have the pen. Spindle, well gun. This one, and I'll go apply scale and 0.5. Doesn't matter. The goal is just to have a tool here. Okay. Let's hide the flange. And let's create a frame like that here. Okay, so let's just create ourselves 4 points. I'm gonna go down here like that. Let's say create the first point, second point, third point, fourth point. I almost redid the first exercise of the training. Right click, create program, and I want to have 2 joint targets, 2 joint motion, and 2 linear motion. Perfect. So and we're gonna call this program, so we'll give it a name. That's very important. We'll give it a name, and the name will be test generate program. Okay, so that's cool. That's gonna give us the chance to explore a few things. So if you want to take what you have now and actually generate something that is usable for the robot controller, you will simply right-click the program and you will have different options. So you have generate robot program as, you have generate robot program, you have send program to robot, and you have start on robot. Let's just talk about the first three ones. Those are the more important for now. So generate robot program as and generate robot program are very, very similar. In fact, they are exactly the same. The only difference is like one, for the first one you decide where you want to save the program to, and for the second one it will go directly to the default folder you selected in the parameters. So in the next video we will discuss about program parameters, so we will see where we can set that value differently. By default, that value will be, I'm gonna open a file explorer, that thing will be document, and then under document you have RoboDK, and here you will have the program that were generated. So I'm gonna empty that folder right now so that we can start from scratch and really see the difference when we have something that appears in this folder here. So if I right click and select generate robot program, you might have seen it real quick, but there will be a loading bar. This program has 4 lines, so the loading bar doesn't take too long. In this case here, we have VS Codium that opened with the actual program. So as you can see, first of all, the name of the program we had here, so test generate program, was kind of translated or imported to as the name of in this case a mod file, because we were using ABB, so it's .mod for module that they are expecting. So those are kind of their text file that are executed within a project. Then you have default headers, you have module test name program here, which is the name of the module, where we used the name of the program here again. Then I'm just gonna open my notes. There's way too many things, and okay, I'll have to split that video in 2 sections for sure. Sorry. So afterwards you have what tool you're using, what frame you're using, and then you have your main program with your different motions. So let's dissect that a little bit. Okay, so I'm gonna bring the robot here, and I'm gonna bring that here like that. So if we go ahead and dissect that a bit more, so just make sure, yeah, we have here our inside RoboDK we have here our set frame 2. So as we can see, our set frame 2 does appear at the top of our program. So this is how it works with ABB. So if we were to generate for another controller, another language, the whole text or the whole program would look different, but the information are generally exactly the same. So here let's stick with ABB for the first example. I like this. I like ABB's language. I think it's very convenient and easy to read. So so you have your set frame, you have your set tool here. As you can see, the name were kept. So it will be the case if the robot controller does accept that. Afterwards, you will have your motion. So you have the first move J. So in this case, we're using move absolute j here to replace the simple move j in RoboDK. Move absolute j, but at the end of the day they are exactly the same. And in the case of ABB, it's expecting after the move j, it's expecting to receive the joint values. So as we can see, 13, 22, minus 2, minus 44, minus 19, minus 41. And if we were to go to target 1, press F3 and look at the values we have here. Don't make me lie. Yeah, exactly the same values. So 22, minus 2, minus 44, minus 19, minus 41. So those values are obviously transferred. I did that twice for two different move j. If we were to move here a bit more, for ABB it's required to give more information. So here you can see you have your velocity, so V500, which will be the default speed. You have your Z1, which represents the rounding. You have what tool is used and what frame is used. So this will refer to the top section. So this is the first section. Then you have your move L. So after the two move J, you have your move L's that are linked here for target 3, target 4. So you will see here XYZ position, so XYZ. So if I was to take target 3, bring it here, and bring that here, so 199, 366, and 344, so that's perfect. Sorry, I saw the 407 here, I was like a bit, anyway. So yeah, the XYZ works. Then you will realize that the joint value here or orientation do not work. It's because ABB is using quaternion, and we are showing quaternion doesn't mean much for, let's say, the human eyes. It's pretty cool mathematically speaking, but doesn't mean much if we just look at it here. So if you want to see it in quaternion, you can, as we've learned in the Euler angle training video, you can go ahead and select ABB quaternion, and now you have one more option here, and you can see here 0, 33, 62, you have 0, 0, you have 0, 94, and you have 0. So that exactly represents the same thing, not in the same format though. So that's it for a very simple program. If I was to go ahead and, so I'm gonna cut it here, and we're gonna select, okay, I'm gonna cut this video here, and we're gonna try something else for the next one.